Welcome to Gumber's Mathematics classes. Hope you liked the video. Subscribe our channel and press the bell icon to never miss another updates.
Hello everyone, today's our topic is section formula in coordinate geometry. Very first, what's the need of this, where we can use this? This is used whenever we have to locate a point, find a point who is placed in between 2 points. Let us consider over here as A and B points whose coordinates are known to us, x1, y1, x2, y2 respectively, and we are supposed to find a point P which is lying on the line segment joining these 2 points A and B, and this point is such that the distance of this point from B is double the distance of this point from A. So it means in this particular case, if we are discussing, we are having the ratio as 1:2, or we can say that if the ratio is given to us, in which ratio we want P to be, so how we can find this? This is all about section formula. For this, let us consider any point AB whose coordinates are known to us and point P whose coordinates we are supposed to find, and in such a way that the distance AP is to PB are in the ratio m1:m2. For this, what we'll be doing, we'll be taking help of coordinate geometry. We'll be finding the coordinates of few of the points, distance of the few of the points with the help of this coordinate geometry. So let's see how we can. So very first we'll be finding this. We'll be joining these, we'll be drawing perpendiculars on x-axis from these 3 points A, P and B. Now again we'll be drawing perpendicular AQ on line PS and perpendicular CP, PC on line BT. These are the perpendiculars. Now we can clearly see that the triangles are similar. Let's see how we can. As we have done, these two are 90-degree angles and this angle is equal to this angle. Why? Because the line AS, line segment AS is parallel to line segment PS. As per our construction, both are perpendicular to x-axis. Therefore, these lines are parallel and these angles are corresponding angles. Therefore, these are equal. Now, with the help of AA criteria of similarity triangle, we can say that these are similar. Let's write the correspondence. Therefore, we have done that triangle AQP is similar triangle. A is corresponds to this, A is corresponds to P because angle A is equal to angle P and angle Q is equal to angle C. Therefore, Q is corresponds to C and this angle P is corresponds to angle B of the upper triangle. Now this way we have got the correspondence. Let me erase this. Now let's rewrite the triangle symbol, this. Now with the help of this we can write the CPST relation corresponding parts of similar triangles. AQ, first and second of this is proportionate to first and second of next. It means AQ upon PC is equal to QP upon CB is equal to AP upon PB. This we have written like this: first second of this upon first second of this, QP second third, BC second third, AP and PB first and third. This is just because of CPST. The triangles are similar. Now from this, let's see with the help of figure what is OAQ. AQ is the distance between these two and this is the distance from where we can find this if we know the coordinates of point P. Q. What are the coordinates of point Q? Q is at the height same as A is having, therefore y1, and it is parallel and it is at the distance of S as S is having from y-axis. Therefore, as well as for P. So it means this is x, y1. And let me rewrite clearly. Its distance is the coordinates are x and y1. X and y1. Similarly, we can find the coordinates from point C. C at the distance, C is having the distance from y-axis as B is having, therefore x2, and from x-axis it is having the distance as P is having, therefore its coordinates are x2, y. Now next thing is AQ. How to find AQ? This is the distance AQ, means distance on x-axis. X-axis means x and x minus x1. Next is PC. PC is equal to, here PC, the distance between x-axis of P and C, that is x2 minus x. And this is equal to QP. QP is equal to Q and P. This distance is equal to distance between the y-axis. So y minus y1. This is equal to y minus y1 divided by CP. BC. BC is equal to y2 minus y. y2 minus y. And now this is equal to AP. AP is m1 and PB is equal to m2. Now we are having, and we are supposed to find the values of x and phi to find the coordinates of point P. Let's see how we can. Now we will be solving these with the help of m1 and m2. Firstly, we will be considering x terms with m1, m2, and secondly we will be considering y terms with m1 and m2. Let's see. Very first, x minus x1, x2 minus x is equal to y m1 upon m2. Let me rewrite this. This is m1, m2. Now cross multiplication, will be getting m2 into x minus x1 is equal to m1 into x2 minus x. Now this can be rewritten as, by opening the brackets we can solve it. This is equal to m2x minus m2 x1 is equal to m1 x2 minus m1 x. Now we will separate out the terms which contains x. These are the terms which contains x. So here x common, m2 minus m1. No, m1 when it will come here, we will be getting it as to be positive. This. This is actually equal sign. Let me rewrite this. This is equal. And here is m1. This m1 we have taken, and this is equal to m1 x2 plus m2 x1. When it will come here, it will become positive. Now we are supposed to find the value of x. X is equal to m1 x2 plus m2 x1 divided by m1 plus m2. This is our section formula related to x coordinate we have found. Similarly, we can find with the for the y. We will be doing this. So very first we will try to learn how to find this. With x2 we have m1, with m2 we have x1, and in denominator we are having the sum of the ratios m1 plus m2. Similarly, for y, if we will be finding y is equal to m1 y2 plus m2 y1 divided by m1 plus m2, which is the sum of the ratios. I hope it's clear, or with the help of this also you can try yourself. This cross multiplication, as we have done for x, you can try for y. Next is section formula. The coordinates of point x, now we are concluding this, of the point P x y, which divides the line segment joining the points A x1 y1 and B x2 y2 internally, then the ratio, in the ratio m1 is to m2, then it is given by, this is x coordinate and this is y coordinate. X will be given as 1 with 2, 2 with 1. m1 x2 plus m2 x1 divide by the sum of the ratios. And similarly for y, m1 with y2, m2 with y1 and sum of the ratios in denominator. Now, and if the ratio is given to us in the form k is to 1, not in the form of m1 m2, if it is given in the ratio as k is to 1, then we can replace m1 by k and m2 by 1. So we will be getting kx2 plus x1 divided by k plus 1. This is same as this, only we replaced m1 by k and m2 by 1. And similarly for y coordinate, y 2 into k plus y1, the sum of the ratio is k plus 1. One more thing is there, it's a special case. Special case is the midpoint of a line segment joining the 2 points. Let us consider we have a line segment whose coordinates are given to us as, there is some technical problem, it's getting continuously. x1 y1 and here also x2 y2, point B, here is point A. We have to find the midpoint of this. It means midpoint means we want to divide the line segment in the equal parts, that is the ratio is 1:1. Here we will be considering m1 is equal to 1 and m2 also equal to 1. So with the help of section formula we can write it as m1 plus m2 in denominator, m1 into, let us consider 1:1. This will multiply by this will multiply by this. We will be getting x2 plus x1 by 2 and y1 plus y2 by 2. This is the midpoint of formula. Here it is. Thank you. Bye bye.